Hwk25 Q5. Stone is thrown vertically upwards with speed 16 meters per second from a point h meters above the ground, and the stone hits the ground 4 seconds later. We need to find the value of h. I've drawn my diagram so that I'm not drawing lines over the top of each other. I've got a little bit of horizontal distance here, but this is a vertical problem, and I need to decide a direction to go positive, and I'm going to choose up to be positive. So S is displacement, not distance, so we only actually need to cover the value of h there. We're going up that way, which means it actually travels or displaces minus h meters. We know our initial velocity is 16. We don't know our velocity as it hits the ground. I don't need to find that one yet. It's accelerating at 9.8 meters per second squared. If I've chosen up to be positive, this is minus 9.8, and it hits the ground 4 seconds later. The equation that connects s, u, a and t is s equals ut plus half at squared. If I plug my values in, minus h is equal to 16 times 4, which is 64, minus 4.9 times t squared, 16. And if I rearrange that, put it into a calculator, that gives me h equals 14.4 meters. In part B, we're asked to find the speed of the stone as it hits the ground. We've got a lot more information on this one. We've got the fact that we know that the displacement is minus 14.4 meters, so we could use that. However, if we wanted to be a little bit safer, we've got enough information to be able to use the information from the question and not our answer to part A, just in case we got that one wrong. We still know that our initial speed is 16. V is what we're trying to find. Our acceleration is still minus 9.8, and it's still taking place over 4 seconds. So as you can see, if we were to use the minus 14.4, there's actually 4 out of the 5 SUVAT equations that we could choose. We just need to make sure that we're not choosing the one that doesn't have V in it. I am, however, going to just use these 4 bits of information and use V equals U plus AT. So, plugging in my values, V is equal to 16 minus 9.8 times 4. So V is equal to minus 23.2. However, we were after speed, not velocity, so we need to make that answer positive for 23.2 meters per second.